Hello everyone. Let's consider the following three well-known power series. The first one is a geometric series. We know that anything of this form will expand like this as long as the absolute value of the r is less than 1. We know that the exponential function looks like this, and we've developed that the cosine function looks like this. Now these aren't the only power series, these are just three of the most common ones that we use. Now let's consider three power series that are just tweakages of the first ones I did. Now the first one we know has the form of the geometric series, but I have to manipulate it a little bit to make it look like it. So I'm going to write it as x over 4 times 1 over 1 minus the quantity negative a fourth x squared, which is then x over 4 times the power series from n equals 0 to infinity of negative a fourth x squared to the nth power. Now when I manipulate that and I simplify that, I can get it all the way down to this form here. Negative 1 to the n to 4, so that'll be 4 to the n plus 1. I have x squared to the n, that's x to the 2n, and then plus 1 more. So I recognize that this guy leads me to here. Now the next one, I'm going to have something of the following form. But now, this is the guy that I'm going to raise to the power. And now when I expand this, I'm going to have a 3 to the n over the n factorial. I'm going to have x squared to the n, that's x to the 2n, but over x cubed, so that'll be x to the 2n minus 3. So the finished form still looks like an exponential, and then finally here, we'll have x squared and then my argument here, 2x cubed all raised to the 2n power. I'll have negative 1 to the n, 2n factorial. Now here the 2 raised to the 2n power could also be 4 to the n. I have x cubed raised to the 2n power, that's x to the 6n, times x squared, that will be x to the 6n plus 2. Now let's consider, I'm starting with a power series and I want to work backwards and ask what function it came from. Now generally, if I write a power series, it didn't necessarily come from a specific function I could identify. But if I look at these two, they both have forms like we just looked at a moment ago, particularly if I look at the denominators. N factorial I've seen, 2n factorial I've seen. So the n factorial x to a power we know looks like an e to the x type of thing, except it isn't there yet. So the first thing I notice is I have this additional plus 4 there. So I can factor out an x to the 4th right off the bat. Now the next thing I notice, I have a 2 to the n, x to the n. I can definitely put those two together in this form. And now that looks just like the exponential function where my argument is a 2x. So finally I can write this as x to the 4th, e to the 2x. Now the next one is a little bit busier, but again I see the 2n in the factorial and that looks a lot like the cosine function. Now I look at this guy here, he doesn't quite match, and again I have this little extra term hanging around. Because it's a minus, I can pull out a 1 over x squared to start with. And then I'd have x to the 4n, but I really need it to be a 2n. So I can also think of this as x squared raised to the 2n. Now if I look at it that way, I've got this term, I've got this term, I can put those together as 1. So now I would have negative 1 to the n, 2n factorial. I have a 3 to the 2n and an x squared to the 2n. That would become 3x squared all raised to the 2n. Now this looks exactly like the form of the cosine function, again, where this is my argument. So finally, we'd have 1 over x squared times the cosine of 3x squared to the n. So in certain situations, if I'm given a power series, I may be able to work backwards and find the original function.